Okay, today in class we started solving systems of equations using substitution. In the systems you were given in class today, one equation was written in standard form, and then you had a second equation that was written in the form of y equals 3x plus 8, or maybe it was written x equals 2y minus 5. And what we did is we took this equation and we substituted the expression back into the first equation. So what you're going to do tonight is you're going to look at solving systems of equations when you don't have an equation where one of your variables is already solved for. So here are your steps. The first step says that you're going to look at both equations and see if one of the variables has a coefficient of 1. Now, when we say a coefficient of 1, that essentially means that we have a variable that does not have a number in front of it. So that's the first thing that we're going to check for. So we're going to look at both equations and see if either the x or the y has a coefficient of 1. The second step is we're going to isolate that variable. So whichever variable has a coefficient of 1, we're going to isolate that variable. And remember, isolate means that we're going to get that variable by itself. We're going to move all the other terms away from it. Then, after we've isolated the variable, we're going to substitute the expression into the other equation in place of the variable. So if we get y equals x plus 5, then we're going to take the x plus 5 and substitute it in place of y in the other equation. And right now, I just want you to really focus on getting the steps written down. And once we have all the steps written down, then we're going to work through some problems together. And that'll make it a lot easier and more understandable for you. Okay, the fourth step is to solve the equation. When we solve the equation, that means that we're trying to find the value of one of the variables. So once again, when you're solving, you're isolating the variable. Okay, and your fifth step is that we're going to use substitution to find the value of the other variable. So in step 4, if we have x equals 3, then we're going to take that x equals 3 and we're going to use substitution to find the value of the y. So those are your 5 steps. Make sure you get these steps down. The first step says to look at both equations, see if one of the variables has a coefficient of 1, and remember that a coefficient of 1 means that there is no number in front of it. We're going to isolate the variable, so we're trying to get it set up so that it says x equals, or it can say y equals. So that's what it looks like when it's isolated. Then we're going to substitute the expression into the other equation in place of the variable. We're going to solve the equation, and then we're going to use substitution to find the value of the other variable. Once we've gone through these 5 steps, then you're going to know that x is equal to some number and y is equal to some number. We're going to write our answer as an ordered pair. And when you write your ordered pair, always remember that x comes first and then your y. Okay, now we're going to go on to example 1. If you did not get all the steps written down, you know that you can back the video up, pause it, give yourself time to get all of your steps copied down, and then you can start playing again. All right, now in example 1, our system is 6x minus 6y equals 6, and x minus 7y is equal to 1. So remember that first step said to look at both equations and see if one of the variables has a coefficient of 1. Well, this variable has a coefficient of 6. This variable has a coefficient of 6. So we can't start with this equation. If we go over to the second equation, this x has a coefficient of 1 because there's no number in front of it. This y has a coefficient of negative 7. So, since this x has a coefficient of 1, we're going to move on to step 2 and we're going to isolate the x. Okay, so isolating x is what we need to do here. Now, on the same side of as the x is a negative 7y. So we're going to do the opposite, which is to add 7y to both sides. This negative 7y, this positive 7y cancels, and we're left with x equals. We have 1 plus 7y. These are not like terms, so you can just write it as 1 plus 7y, or if you prefer, you can write x equals 7y plus 1. Those expressions are equivalent. Okay, so this is step 2. This is what step 2 tells me to do. Now in step 3, it says to take this expression and substitute it into the other equation. So we're going to take this 7y plus 1 or the 1 plus 7y, whichever you use, and we're going to take them over here and put them in the place of the x. Okay, so our step 3, we're going to write the 6. Instead of writing the x, you're going to put in one of these expressions. Not both of them, one of them. So I'll do the 7y plus 1, close parentheses. Now write the rest of the equation. Minus 6y equals 6. All right, that's the substitution. Step 4 says to solve. So I'm going to group these steps together, step 3 and 4. You're going to do 6 times 7y, and you're going to get 42y. 6 times 1 is plus 6 minus 6y equals 6. So here we're going to combine like terms that are on the same side. So you have 42 minus 6, you get 36. So that's 36y plus 6 equals 6. Okay, then the next thing we want to do is we're trying to solve for y, so we got to isolate the y. I'm going to subtract 6 from both sides here. These cancel, and I get 36y equals 0. Now we're going to divide by 36, and you get y is equal to 0. Now we're at step 5. Step 5 says to use substitution to find the value of the other variable. So now I'm going to take this y equals 0 and put it right here in the place of y. So for step 5, I know that x is equal to 7y plus 1. Now I know that y is equal to 0, so x equals 7 times 0 plus 1. X equals 0 plus 1. X equals 1. So I know that y is equal to 0, x is equal to 1. Remember, our ordered pair is written in the form of x, y. So my solution for the system is 1, 0. Any questions about the first example? Any questions that you have, make sure you note those questions on your note sheet. Okay, we're going to move on to example 2. All right. Okay, for example number 2, my system is 21x minus 3y equals 60, negative 7x plus y equals negative 20. Okay, your first step tells you to study the two equations carefully. And we're looking for a variable that has a coefficient of 1. So we're going to add 7x to both sides here. And you're going to get y equals 7x minus 20. Then we're going to take this 7x minus 20, substitute it in here. Then I have 21x minus 3 times 7x minus 20 equals 60. And I get 21x minus 21x plus 60 equals 60. It's negative 21x and a positive 21x cancels. So I have 60 equals 60. Okay, there are no variables left. So now we need to determine if this statement is true or false. 60 does equal 60, so this is a true statement. Whenever your variables cancel out and you're left with a true statement, then this is one of the special cases. Because it's true, then it means that we're going to have many solutions. And if you think back to when we were graphing, whenever we had many solutions, then we had coinciding lines. Okay, so there's number 2. So write in on your note sheet any questions that you may have about number 2 at this point. Okay, now when you come to class tomorrow, the expectations are that you will be able to work through at least one problem on your own. So what I'm going to do is I'm going to give you 2 problems to try. So what I need for you to do right now is you're going to use your notes that you've taken tonight. And these 2 problems will be your warm-up tomorrow. So make sure you try them when you get to class. Then it'll just be a matter of us discussing the warm-up and not waiting 5 minutes to get the problems done. So these are your 2 warm-up problems for tomorrow. Make sure you've taken notes. Go back and watch the video as many times as you feel is necessary for you. And make sure you've written down any questions that you need answered. See you tomorrow.